Hello students, today we talk about homogeneous and heterogeneous systems and the reactions and the catalysts. Homogeneous reactions are reactions in which the aggregate state of reacting substances in homogeneous systems is the same or in the volume of one phase. So the next heterogeneous reactions. Heterogeneous systems consist of several phases. So reactions in which reactants are in different aggregate states and they are called heterogeneous reactions. So last one is a catalyst. Catalysis change in chemical rate due to catalyst. So
let's see experiment. In this video, we will see a homogeneous catalyst. In a demonstration to show a solution catalyst, we will heat a solution of sodium potassium tetrate. So we will add a solution of hydrogen peroxide. The reaction very slow initially, even at 60 degrees Celsius. We will then add some cobalt plus 2 ion. The cobalt ion forms a complex ion with the tetrate ion. The solution turns green due to the formation of this complex ion. So the reaction becomes very rapid. We will see the revolution of carbon dioxide gas, and so at the end of the reaction the solution turns back to pink, showing the reaction of the catalyst. The next experiment about a heterogeneous catalyst. We will demonstrate a solid-state catalyst. We'll place a small amount of acetone in the bottom of a beaker. We'll heat a copper wire and suspend it from a stringer rod above the acetone. The copper catalyzes the oxidation of the acetone, so the reaction is exothermic, which causes the catalyst to glow red hot.
Good. Oh, Emily Hansen, are you here? Really? What kind of dissertation? Okay, I will do your task. Everyone, today my dissertation name is the rate of chemical reaction. I can identify 5 factors that affect the rate of chemical reaction: the chemical nature of the reacting substance, the state of subdivision, one large lump versus many small particles of the reactant, the temperature of the reactant, the concentration of the reactant, and the presence of the catalyst. What is the reaction rate and formula? Rate of reaction equal amount of reactant used plus time taken for the consumption of the reactant. Rate equal constant The reaction rate or rate of reaction is the speed at which chemical reactions take place, defined as proportional to the increase in the concentration of a product per unit time and to the decrease in the concentration of a reactant per unit time. What is the rate of reaction important? The rate of reaction is powerful diagnostic foot. By finding out how fast products are made and what causes reaction to slow down, we can develop methods to improve production. My colleagues, thank you for attention.
Hello students! Today's our topic is law of active masses. Chemical reaction is directly proportional to the product of the concentration of the reactants, and this is called the law of mass action. The law of mass action is a fundamental law, is a basic of many methods of analysis in analytical chemistry. It describes the quantitative amount of substances participating in chemical reactions in an equilibrium state. Any analytical reactions can be considered a reversible process, but because the rate of the reverse reaction is slow, it cannot be remembered. In some reaction is directly proportional to the product of the concentration of the reactants, and this is called the law of mass action. The law of mass action is a fundamental law, is a basic of many methods of analysis in analytical chemistry. It describes the quantitative amount of substances participating in chemical reactions in an equilibrium state. Any analytical reactions can be considered a reversible process, but because the rate of the reverse reaction is slow, it cannot be remembered in some cases. Two chemists generally express the composition of a mixture in terms of numerical values, relating the amount of the product to describe the equilibrium state. Maximilian Galbraith and Peter Weige, building Claude Berthollet's ideas about reversible chemical reactions, proposed the law of mass action in 1864. These papers in Danish went largely annotated, as did the later publication in French of 18. An elementary reaction, we need to write the law of mass action can be written as a kinetic equation of the form. We need to write for complex reactions in general, this relationship is not satisfied. Nevertheless, many complex reactions can be conditionally considered as a series of successive elementary steps with unstable intermediate products, formally equivalent to the transition from the initial state to the final state in one step. Such reactions are called formally simple. For formally simple reactions, the kinetic equation can be obtained in this form. Please write with me. We need to write again here N1, N2 and N3, the reaction order of substances A1, A2 and A3 respectively, and sum of N equal N1 plus N2 plus N3 is overall order of reaction. N1, N2, N3 may not be equal to symmetric coefficients and not necessarily integer. N, under certain conditions, can be equal to 0. In chemical thermodynamics, the law of mass action relates the equilibrium activities of the initial substances and the reaction products according to the reaction. We need to write this formula. In practice, in calculations that do not require special accuracy, activity values are usually replaced by the corresponding values of concentration for reactions in solutions or partial pressures for reactions between gases. In this case, the equilibrium constant is denoted Kc or Kp, respectively. For the first time, the law of mass action was derived from the kinetic representation by Goldberg and Weiss, and its thermodynamic derivation was given by Van Gogh in 1885. Come here. It's written by this formula.